Eighth graders, today we're going to talk about rational numbers and all the attributes of them. This one's kind of long and it's got a lot of information, so make sure you take really good notes. Okay, so the first thing, we're just gonna, changing fractions to decimals and decimals to fractions. So fraction to decimal, we just went over in 3-1. So if you have a fraction and you need to make it a decimal, that is when you long divide. So you already have some practice of doing that. Numerator by denominator. Okay, now the other ones are new, so we're going to go, I'm going to specify here, terminating decimal to fraction. So what if you want to go the other way? What if you have a decimal and you want to change it to a fraction? Okay, so the first thing that you have to do is you have to use the place value. So place value is sometimes an issue. And I'll say after you use the place value and simplify. Place value can be a bear for some. So like you've got your decimal point, and then we're just going to do a few place values till you kind of get the hint. Place value is kind of our opposite of the place values on the left. So this is the ones place value, also can be called the units place value. But after the ones to the right, there is no oneths, it's tenths. So this is a tenth here. And then after tenths, it's kind of like, the next one over here to the ones was the tens. The next one after that is hundreds, then it's hundredths. So after that, they kind of repeat. After 100, 999, then you have 1,000, but it's a thousandth with a THS. And then after 1,000, you have a 10,000th, just like you would have a 10,000 on the other side. And after 10,000s, 100 thousandths. And after that, a million millionths. So these on this side have a THS on them. So just stressing that they do. The ones on the other side do not. So that's how they're different. All right, so this is 1/10. This is 1/100th, 1,000th. So these are actually just fractions, 1/10,000th. And 100,000th, and it just keeps going and adding a 0. Another way to remember is the tenths place is one place value. It has 1 0. The hundredths is 2 zeros. There's 2. Thousands had 3. 10,000s has 4 zeros. Because it's the fifth one out, now it's got 5 zeros. So that's just another way to remember. All right, so they're going to give you some fractions or mixed numbers, and they're going to want you to change it to a decimal, or back and forth, a decimal to a fraction. So this one's a decimal, 4.76. It is a terminating decimal. So my terminating says use the place value and simplify. What is the place value of the last digit in the number? That is the hundredths place value. So this, another way to, if you did it in words, 4 and 76 hundredths. So the last digit will tell you what place value it is, and it will also tell you what the fraction is. This, when you say this, you are saying the fraction. 4 and 76 hundredths. You just made it a fraction. But then, of course, I said to simplify. So if you need to simplify, you can at least divide them by, if they're both even, you can divide them both by 2. So 76 divided by 2 is 38 over 50. We can do it again by 2. So I really should have used 4 in the beginning. So that's 17 over 25. So the final answer here would be 4 and 17/25. Okay? 19/25. Having a day today. 19/25. Okay. So what if it's negative? Okay, so negative 2.008. So you would say that's a negative 2, and the 8 is in the third place value. So that means that the place value has 3 zeros. So I have a thousandth situation. It is an 8,000th situation. So to say that properly, negative 2 and 8 thousandths. So we can divide that by 2 if we need to, maybe more. So 8 divided by 2 is 4,500. Do it again. 2 250ths. I can do it again. 1 125th. So really I should have divided by 2 times 2 times 2. So I just should have divided by 8 right away. But the final answer for this one, we have -2 and 1 125th after it's been simplified. Okay, another one. -5.67005. Okay, so -5 and 67,005. Now remember, it's 1, 2, 3, 4, 5. It's the fifth one out. That means it's got 1, 2, 3, 4, 5 zeros. It's 100,000. So 67,005 100,000ths. I know that seems like a lot, and I'm pretty sure you're not going to get one this large in your homework, but we were just working on it. So when I look at 6705 and I look at 100,000, I know at least 5 goes in there. So if I divide that by 5, 67,005 divided by 5, 5 goes into 6 once, goes into 17 3 times, goes into 20 4 times. Now, just because I had a 20 here doesn't mean I'm done. I have to drop, sorry, I dropped 1 0. I got to drop the second 0. 5 does not, every time you drop it, you have to ask again. 5 does not go into 0. Then if I wanted to get technical, 0 times 5 is 0. Then now you can drop the last 5, and 5 goes in there once. And now when you don't have any more to drop, then you may stop. So on the top there, it's 13,401. And then if you want to take 100,000 divided by 5, just take 100 divided by 5, which is 20, and then add on the 0. So 100,000 divided by 5 is 20,000. So it is possible to have a crazy number like -5 and 13,401 20,000ths. It's not very much more, or actually less than -5 in this case, but that's kind of what's going on. So if you have the need to change a fraction to a decimal, you need to use the place value and simplify. So if you wanted to take a second here, I would have you do some, independent practice. So -36 and -2 1/8 and 1. If I wanted you to take those a fraction to a decimal. Well, the fraction, -36 over 1, that is just, it's a whole number, so that's just going to be -36. So its fraction and its decimal, its fraction is actually over 1, its decimal is just -36. B, if you needed to do that, you'd take -2 and you would have to go over and do 1 divided by 8. So you would go 8 goes in there once, which is 8, drop a 0, 8 goes in there twice, which is 16, 40.125. So this is -2 and 0.125, so you're just going to put those together, -2.125. And then what is 1 as a fraction? Well, it's just 1. So this is the fraction, this is the decimal. So if they want something as a fraction, especially with these two, just put them over 1. It's that easy, but if they don't, then it's the other way. Now they also might want you to, just because I think this is what they'll probably ask you to do, -2 1/8, and if they say write that as a fraction, I think all they mean to do is write it as improper. So just a little reminder, how you do that is you take 8 times 2, which is 16, plus the 1 is 7, so it's -17 over 8. Notice I kept the negative on the top on that numerator, so they may want you to do that. It just depends on what the directions say. So make sure if they ask you to write it as a fraction, make sure it looks like a fraction. If they ask you to write it as a decimal, you're going to have to go into a little more work. All right, so the next part they've got, here are your sets of numbers. You're going to need these, and you're going to need them often. So the first set that I'm going to talk about is a natural number. Natural numbers are the numbers that you started counting with when you were very, very small. So it starts with 1. Usually I don't start counting with 0. dots mean that they go on forever. Notice there are no decimals in natural numbers, okay? They are the counting numbers. So they may ask you what set certain numbers belong to. Well, natural numbers would have all the counting numbers. After the natural come the whole numbers, which are very similar. The only difference between the natural numbers and the whole numbers is that the whole numbers have a 0. They go on forever just like natural. So all you need to do is the natural numbers with 0. So that is the only difference between natural and whole, is just the number 0. Integers, which we've been adding and subtracting, are the negative numbers without decimals, and 0, and the positives. Okay, so there's still no decimals here. There's no decimal answers in natural, whole, or integers. So just be aware of that. Those are your sets. Now the last set they talk about is the rational set, which that's what the title of this whole entire section is. Rational numbers are anything that can become a terminating or repeating decimal. That's what a rational number is. So that includes a lot of things. So the rational numbers. If I start with, do rational numbers involve the natural numbers? Can a natural number be rational? Can you take these natural numbers and aren't they terminating? The number 1 is just 1. There's no decimals that are going after that. So natural numbers belong here. What about whole numbers? All of these whole numbers are terminating, so whole numbers belong here. Integers. None of those have any decimals in the first place, so they're all terminating, so integers belong there. Okay, fractions. If you divide fractions, you're either going to get a terminating or a repeating decimal, so all fractions belong there. All mixed numbers belong there. All improper fractions belong there, okay? So basically, if you can repeat or terminate, you belong in the rational numbers. So what they're going to do, this would be the directions, name all the sets these belong to. So you've got 1, 2, 3, 4 sets you can choose from. Okay, so we're just going to start with, here's the -6. You're just going to go through, does it belong? Is -6 a natural number? Do you count with it? No. Okay, is it a whole number? No, whole numbers are positive numbers with the 0. Is it an integer? Yes, so it's an integer. And since it's an integer, it is also rational because integers are terminating decimals, so it's a rational number. So the -6 belongs to 2 of our sets. Okay, -2 and 3/8. So is -2 and 3/8 natural? Well, we don't count with fractions, so it's not natural. It's not whole because, you know, it's between 2 wholes. And then integer, it's got a fractional part to it. Integers do not have a fractional part or a decimal to them, so it's none of the first 3. All it is a mixed number, which makes it just rational. C, the number 3. I definitely count with the number 3, so it's natural. And it also belongs in the whole numbers up there. So it's whole. It's an integer. And it is a terminating decimal, so it is also rational. So it's very possible that some of these will belong to all 4. D, the square root of, and I know this is the first time you found a square root, the square root of 16. The square root just asks what number times itself is 16, and that's 4. So the square root of 16 is 4. Now you're judging 4. Don't judge the square root of 16, judge the 4. 4 is just like 3. It's natural, it's whole, it's an integer, and it's rational. So it is possible. Now let's say you get a square root where you can't find a nice number times itself to get there, like the square root of 23. That one's not a friendly one, so that one would be none. And we'll talk more about that in a few sections beyond this, but for now that's going to be none. And then what about something like this, 0.0097? Okay, we don't count with it. It's not a whole number. It's not an integer because integers can't have decimals in them. But it's a terminating decimal, which means it can be rational. Just because it terminates like that, that makes it rational. So that's kind of what they're going to have you do there. Now, changing gears. You've done terminating to fractions. We have not done repeating decimals to fractions. All right, so this year we're just going to focus on a couple. So, if it's a one-digit repeater, like 0.7 repeating, what this means is that here's the terminating decimal, 0.7. This one's the terminating. Terminating decimal, you use the place value, 7/10. If it repeats, all you're going to do is do 7/1 less than that, which is 9. If you take 7 divided by 9, you'll get 0.77777 on your calculator. So just realize, don't get the repeating ones messed up with the terminating ones. They are two different things. Now, what if it has two digits that repeat, like a 0.71, and both of them are repeating? Okay, similar to 0.71 without a bar, but it's not the same. Without the bar, it's 71 over its last place value, which is 100. This one is not over 100, it's over 99. It's one less than that. So if you take 71 divided by 99, you'll get 0.717171. And it kind of goes on like this. If it's three digits, like 0.824, and then like this one, 0.824 without the bar, this is 824 over 1,000. And then you would simplify it. We're not going to take the time to do that right now, but you would be expected to. This one is 0.824. It's 824 over one less than that 1,000, which is 999. So just one thing to remember if you're dealing with repeating decimals, to just remember it's over 999 or 999. So a couple examples. What if you had negative 2.8 repeating? So when I look at that, just the 8 is repeating, so that's a one-digit situation. A one-digit situation makes it over 9. So the whole number is negative 2, and it's not 8/10, it's 888, so that makes 8/9. So that's kind of how that works. 0.64 with a repeating bar. That's going to be 64, but it's not terminating, so it can't be over 100. It has to be over 99. So just be aware. That's kind of how these work. And then what if it's something, different like this? 2.008, and the 008's repeating. 2, and we're not actually going to put the 008. It's just going to be 8. But still, 1, 2, 3 numbers are repeating. So it's 999. So just realize that's kind of how it works. There's one digit, it's a 9. If it's two digit, it's a 99. And if it's three digit, it's 999. So that's kind of what we're going to go for there.